Yesterday we looked at P and Q. What's missing there? Yeah, this is what we're going to do today. And yes, put it all together, okay? So here is a graph of y is f of x equals x minus 2 squared. Do we agree? We did every question assigned yesterday. We absorbed it. We understand it. Does that make sense? You see a minus 2 and this thing is 2 units to the right. Compared to our, as always, we're always comparing it to our most basic quadratic y equals x squared. Yes? Okay, good. Now, we're going to put a 2 in front. We're going to call this thing y is 2 bracket x minus 2 squared. What's it going to do? Well, let's find out. Quickly, with a little table, I'll do it here. I'll do it here. Okay, couple of values. Well, a nice one is 2, because then 2 minus 2 is 0. And then I've got 0 squared is 0, and I get the same point, right? Right there. So that doesn't change. And then maybe I want to take 1 point right of that. 1, 2, 3. See what happens. I get 3 minus 2 is 1. 1 squared is 1 times 2 is 2. So before I got 1, 1 squared is just 1. Now I get 2. And I want to take a point left of this vertex. I should have asked you what it was. It's a vertex point. And I'm going to try 1. So 1 minus 2 is minus 1 squared is 1 times 2 is 2.
Good morning, Valley View. A reminder to all band and choir students, we have a concert today. Please be in the band room at 6:30 dressed in concert blacks with your bikes tied. And another reminder to all senior band students that you will have a rehearsal today at lunch. There will be a bake sale Thursday, tomorrow at long break and lunch, just outside the gym. Come out and support the Valley View track and field team while enjoying some goodies. I like Rice Krispies. Congratulations to the Valley View golf team who qualified for provincials yesterday with a second place finish at the Okanagan Championship. Well done, way to go. All peer mentors need to meet in the leadership room to get a t-shirt and supplies, then go directly to the bus loop at the beginning of long break. See you there. There is a message in the office for Matea Portaland. Please come and get your message. That's it. Have a good day, everyone.
Okay, is that enough points to know what this thing looks like? Yeah, maybe I got a couple more. Get a couple more. Let's try. I did that one. Let's try 0. I like 0. Okay, so if I put 0 in, I get 0 minus 2, which is minus 2 squared, which is 4, times 2 is 8. What did I get before in a regular graph? Looks like I got that point right there. This is 5, 6, 7, 8. And let's try this guy right here, which is 4. 4 take away 2 is 2. Squared is 4, times 2 is 8. And maybe I didn't even have to do that. If my knowledge is pretty good, maybe I just know that this thing is symmetrical. I only need to get the points on one side and then kind of flip it over. Yes? But I think that's enough to know the shape of this thing. Looks like that. So, how would you describe the shape of that graph compared to not x squared, but x minus 2 squared, which is the black one? A little more inwards, a little thinner, skinnier. Was it a translation? No, because that's the same shape just moved around, right? That's what we used to describe Q, which was up or down, and P, which was left or right. So this is not the same shape, okay? My vertex did not move at all. That was the same point. So what happened? Here's what happened. Just common sense, look at this. What's that 2 going to do? Whatever this thing does, whatever happens here with this graph, it's going to be times 2. So all the y values are twice as big as they were. Does that look like what happened? This was 1, and now it's 2. This was 4, and now it's 8. Okay? Every y value is double what it was. Okay? So that's what having a being 2 does. Doubles all the y values. So let's see what this guy does. Y is, what if a is a half x minus 2 squared? Any guesses? All the y values are half what they were, yes. Algebraically, numerically, that's what happens. But as far as the shape goes, what do you think, Amanda? Is that a good guess? Instead of being skinnier, it'll be fatter? Yes? Wider? Okay. Well, let's just plot a couple of points. Now, if I put in 2 again, I get 0. I don't care what a is. It's still going to be 0. That's going to be the same point. And let's just try that guy there. 1, 2, 3. 3 minus 2 is 1. Squared is 1. Times a half is a half. That's still 0, right? So it used to be 1 squared is 1. Now it's a half. And guess what's going to happen if I put 1 in here? Negative 1 squared is 1 times a half is, it's also a half. Or 0.5 if you like decimals. Okay, so just looking at those 3 points, yeah, I think that's a good guess. I think everything's going to be half what it was. If this thing was 4, it's now going to be 2. Okay? And vice versa. Symmetrical, that point is 4 up, so it's going to be half what it was, which makes it look wider. Okay? So no translation. What a does, so far, we found out, it makes it thinner or thicker, if you will. Wider is, I think, is a better word. Except we don't have those words. In math, we got a couple of different words for these. Compared to the graph of y equals f of x, which was x minus 2, what did the 2 do? It's a vertical. Which one looks like it makes sense here? And actually, I'm talking about the blue one, so let's make it all blue. When it was a 2, it made it thinner. Which word looks like it kind of would make more sense? Or does any? Yeah. If you think of this black thing as a rubber band, okay, rubber band parabola, if I grab those arrows on the top and I pull it, if I expand it up, will it make that blue shape? Okay. Again, I don't come up with this terminology, guys. I just deliver it, okay? Yeah, that's called an expansion. Does that kind of make sense? A little bit, at least? It's a vertical expansion. Hold on, not there yet. By a factor of 2. Because there's a 2 in front, like I said, all the y values are twice what they were. It makes it skinnier. That probably makes more sense to you. But here's the word we're giving you, okay? That is a vertical expansion by a factor of 2. All right? And D, compared to the graph of that, what did half do? Well, we saw it made it a little wider, but we're going to call it, well, now you know what the one is, you know what the other one is. So what might help is visualize this. If this, I'll draw it again. If that was like a piece of spring steel and I bolted it to the floor and you put something heavy like a desk on top, would that compress it? Okay, you visualize that? Would that make it go like this, depending on how heavy this thing is? Okay, that's all I got for you, okay? It's a compression. Fatter is a compression, thinner is an expansion. And this is a factor of whatever number A is, that's what it is, a factor of a half. They're half as big. All right? So any point on the graph is half as big. If they're talking about a y-intercept, well, yeah, that's half as big as well, okay? So, describe the effect of the parameter A. What does A do? Makes it skinnier, makes it wider. Or, we got another word. Stretch. An expansion or a compression is called a stretch. Don't blame me. I'm just the messenger. Okay? That's what we got. All right? Right here. In math, the general name given to an expansion or a compression is a stretch. It's a stretch by a factor of A. Okay? Now, what if A was not 2? What if it was 3? What if it was 4? What if it was 16.8? In general, if A is, what does this say? Greater than 1, like 2, 3, 4, 5, 16.8, the parabola undergoes a vertical expansion. Okay, if it's bigger than 1, it's going to be thinner. It's going to have an expansion. And this looks a little bit odd, but does 1/2 fit in this category? Is it bigger than 0, less than 1? Yes. Can you think of another proper fraction that fits in this category? 3/4, a quarter, okay, 2/3. Those are all proper fractions. They all fit in this category. But I can't just use the word fraction because technically that's a fraction. And that's not in this interval, is it? That's 2, which is here, okay? So I can't say fraction, but I know you're looking at that and you don't like it and you want to think fraction, but be careful when you use the word fraction. It has to be a proper fraction. Right? So all of those fit. So yes, we did one example with a half because that's probably the nicest one, the nicest number from 0 to 1, but it fits with all these other guys too, okay? It'll be a compression if it's less than 1 but greater than 0. Lots of info, huh? Something else going on too. What if A is less than 0? What's another way of saying something's less than 0? Yes. Did I give you this on your hand-in project? Which I hope y'all handed in, because I'm handing them back, and after an hour it's going to be worth nothing. Did you observe what happened? Yeah, good. So this is our most basic graph. Y is x squared. So if I just do that, again, you don't know the terminology. I just wanted you to observe what happens. And you use lots of colorful language. Some of you said, well, all the positives became negatives. Because again, what's this going to do? Whatever x squared is, you put a minus in front, it just makes it negative. So if you had that point, it just became negative. If you had this point, 2, 4, it just became negative. And of course, this thing's symmetrical, so I can do the same on the other side. That's what happened. So yes, they all became negative. What's another word you guys used? Common one was flipped. Perfect. Okay, you described exactly what happened. It flipped. Where did it flip though, if I wanted to be a little more particular? It flipped over that line, which happens to be the x-axis, right? So now, if I got more than one thing going on, if I have a negative and a 2, the negative makes it negative, but what does the 2 do again? All the y values are twice what they were, and it's negative, so yes, this thing is skinnier. So it's not 1, it's 2. And it's not 4, it's 8. Okay? So it's narrower. The correct word is vertically expanded. And what's a better word for flipped in math? Inverted. Okay. Here's what we're going to call it. So y is negative x squared. What happened to my vertex here? Anything? Nope. It's in the same spot. But does it have a minimum if it opens down? If it gets flipped, is there a minimum? No. These arrowheads mean it goes on forever and ever and ever, right? But it does have a maximum, yes. Okay? And the maximum point is 0 for this guy. What happened to my equation of the axis of symmetry? Did it change? Nope. It's in the same spot because my vertex is in the same spot, so it's still x equals 0. But here's the correct wordage. It's a reflection in, or I prefer over, the x-axis. Okay? So flipped worked, but now you got the proper language for it. Okay? Does that make sense? Again, think of this just like an axis of symmetry. That's like a mirror. If you put a mirror there, this is what you're going to see. It's a reflection. Okay? Over the x-axis. So if I do 2 of these transformations, what happens to the vertex if it gets flipped? Nothing. What happens if I make it thinner or thicker? Nothing. Okay, it doesn't get moved around. It's the same spot. But this has a maximum because it got flipped. The equation of the axis of symmetry is the same. And now I have to write 2 things here. It's like I have P and Q, but it's not. It's just A. So the negative is a reflection over the x-axis. And what does the 2 do? Which way? And then, like I said, all our parabolas are going to be opening up or opening down. So yes, it's always going to be vertical, but let's put the word anyway. Okay? So that's a vertical expansion because this is 2 is greater than 1. And then we want to write how much? By a factor of 2. Okay? It doesn't matter what order you put those in. What's the other word for an expansion or a compression? They're both stretches. Okay? Lots of biology going on, eh? So in general, if A is negative, okay, I'm not going to write this again, but you get a reflection and a stretch. So how does that compare with that? Reflection in the x-axis. And I don't know if this is helpful, like, because what's A? Is it a half? Is it 3? We don't know. Here's a good table, though. So let's put it all together. Okay, that's everything we got in the last 2 days. In a handy-dandy little cheat sheet, if you will. Transformations on this quadratic, which I'm going to call in vertex form. So let's do what we did yesterday. P is a horizontal translation. Again, make sense of that in your head. You know what it looks like. It kind of looks like it does the opposite thing. Okay, so I don't know if this helps you. Q is the easy one. If it's positive, it's up. If it's negative, it's down. And what we got today, there's a couple of options for A. First of all, if it's negative, it reflects it in the x-axis. Okay? And if it's greater than 1, it's an expansion vertically. And if it is between 0 and 1, it's a compression. Think of the word fraction, but again, there's some fractions that aren't between 0 and 1. But if you want to think fraction, I'm going to say, okay, that should work. Okay? Now, why do I call this vertex form? Because P and Q are the coordinates of the vertex. Nice. Okay, it's going to be helpful. And the axis of symmetry is always where the vertex is. It says that in your notes before. But P, that first coordinate of the vertex, that is the equation for the axis of symmetry. Okay? So P tells you where the axis of symmetry is, and Q helps you determine the range, which isn't in this table. Okay? Loads of information. Couple of questions. Consider this function, and it's a function because it's f of x, and if you want to think that's y and think it's an equation, that's just fine. Okay? So I got some stuff going on. Compared to our most basic graph, y equals x squared, what does that do? What does that do? What does that do? Okay, well let's start. We want to go from left to right. What does the 2 do? That's A. And that's going to do a what? Look above in the table. That is a vertical expansion. All the y values are going to be twice what they were by a factor of 2. Next thing, 4. What does that do? That's P, which made it go horizontally. So that's a horizontal translation. How far? 4 units. What direction? Left. Good. And the easiest one, Q minus 3. That is a vertical translation 3 units down. Okay? And that's going to be more confusion at this point than what it's worth. So let's glance over it. Okay, it kind of gets towards what order we do these in. And like I said, you go left to right. Okay, stretches, reflections, these can be done in either order, but you want to do translations last. Okay? Describe how the graphs of the following functions relate to the graph y equals x squared. What's going on here compared to this one? I've got a minus and I've got a quarter. What does the minus do? That's a reflection in the x-axis or over the x-axis. And what does the quarter do? That's a vertical what? Compression. Good. Quick learners. By a factor of quarter. Okay. All the y values will be as quarter as high as they were. That will be a fatter graph. It'll be compressed. And let's throw you a curveball. This is vertex form. If it's not in that form, you want it to be in that form, because you want to see what A, P, and Q are. Is there anything here in vertex form? No. It's, remember, like y equals mx plus b? If you got a 2 there, you got to get rid of it. Because that, you don't know what the slope is, you don't know what the y-intercept is until it's solved for y. So it's the same thing. I got to get rid of that 1/3. How do I do that? By multiplying both sides by 3. So this is how we want to look at it. I multiplied it by 3, but I put the 3 in front of the brackets. Okay? In other words, that's A. A is not a third though, A is 3. Okay? Now it's in this form. What does that do? It's a vertical. We can abbreviate a little bit. Okay? Vertical expansion by a factor of 3. And what does a 6 do in the brackets? That's P, that's a horizontal translation, 6 units. Which way? Yeah, in the negative direction because it looks like a +6. Okay, couple more. So that's an equation. You're describing what the changes are compared to y equals x squared. Now we're going to give you it in words and you're going to write the equation. So just like you did yesterday with P and Q, but only now we got all 3 things going on. Compared to y equals x squared, we've got a reflection in the x-axis. What's that going to do? It's going to put a negative there. We've got a vertical stretch by a factor of 1/3. So you don't have to worry about the word expansion compression because it tells you it's a third. Okay, so that's kind of nice. And then I've got 7 units right. Where do I put that? In the brackets or at the end? In the brackets. Plus or minus 7? 7 units right, plus or minus 7? Minus 7. And then they don't say anything about up or down, so if you like, Q is 0. But you don't have to write that. Same thing, okay? Okay? So 3 things going on. Reflection, negative. Stretch, 1/3, and 7 units right, so that should look like -7. Okay, I'm not too concerned about this right now. You'll get a question kind of like that, but it's a little more self-explanatory on how to answer it, okay? So, what happens with my vertex then? Here's my most basic graph. You should have a mental image whenever we see y equals x squared. That's it. So what happens when I reflect it? As far as the vertex? Nothing. What happens if it's 1/3 stretch? Nothing. But what happens if I move it 7 units right? It's now over there. That's what this parabola will look like. Okay? Compared to y equals x squared, this thing will be flipped, fatter, and moved down the line 7 units. So, my vertex is now 7, 0. Okay? Another table. Compared to y equals x squared, oh, we're just jumping right into the, what's the vertex? What kind of form is this? It's vertex form. That tells you what the vertex is. Okay, the vertex is PQ. So if you see a negative there, That's P. Or ask yourself, when you see plus 3, what happened? It went 3 units left. And then 4 units down. That's Q. Okay? Without drawing a picture, which may help, and you're allowed to do that, of course, that's where my vertex is. So the vertex is PQ, but the form of this equation has a negative in front of it. So I hope I'm not going to confuse you, but is that exactly the same as this? Negative, negative becomes a positive. That's P. Because the form of this equation is x minus p. X minus p is negative 3. Okay? Q is the same. If it's positive, it's positive. If it's negative, it's negative. But like I said, this p thing does the opposite. Okay? Yeah. Okay? So, if that's where my vertex is, and if I know the sign is negative, does this thing have a max or a minimum? It has a maximum. It got flipped. And what is the maximum value? You see where the vertex is? If it's flipped and my vertex is, a picture may help. That's what that thing looks like. Let's make it bigger. Okay, so when I talk about maximum, I'm talking about range. That's the maximum. It's at negative 4. So speaking of range, since I was just talking about it, what is the range of that graph? It's all the values of y. Is it greater than negative 4? Less than or equal to negative 4? Where y is a set of all real numbers. Okay? Everything from here down is my range. Because it got flipped with that negative, now this sign's going to be opposite. Axis of symmetry. Up above in the notes, it said wherever the x-coordinate of the vertex is, negative 3, that's the same as the axis of symmetry. Okay? Lots of information. Finally, what's the domain? Yeah, that's the easiest part here. Nobody should get that wrong on the quiz or the test. Okay? I don't care where this parabola moved. I don't care if it was flipped or not. It's always all x values because it still goes left forever and ever, still goes right forever and ever, and I got every point in between because it's continuous. Okay, last one. What's the vertex here? It's in this form, x minus p. P is 9. What's q? Yeah, if you like, put it in there. Okay, that thing got moved 9 units right, not up or down, so my vertex is not 0, 0, it's 9, 0. Does it have a max or a min? It has a minimum because it's positive. It didn't get flipped. It looks still like that. Okay? If there's a minus, it looks like that. And what's the value? 0. That's the y-coordinate of the vertex. Axis of symmetry. Look at the x-coordinate of the vertex. X is 9. This is the easiest one. What's the domain? X is all real. What's the range? The vertex y-coordinate tells you what the range is. And it opens up, so it's everything from that point up, and that point is 0. Okay? So again, the vertex tells you your range and it tells you your axis of symmetry. But I know it's a lot going on. Okay? So we're going to have a little group project tomorrow to help reinforce this, and then promise me you're going to keep it in your head till Tuesday.